Now, if you're analyzing a pedigree to determine if it's compatible with X-linked recessive or X-linked dominant, let me give you a clue. You should always include the sex chromosome content with each individual in the pedigree. In other words, the females are always XX, the males are always XY. Now, it's important to remember that for X-linked traits, females can be homozygous or heterozygous. However, males cannot, because males only have one X chromosome. So therefore, the term used to describe a male's genotype for an X-linked trait, or a Y-linked trait for that matter, is hemizygous. In other words, the male will be hemizygous for either the recessive allele or the dominant allele if it's X-linked. He can only have one copy. So if you're assessing a pedigree for compatibility with X-linked inheritance, first thing off, put the sex chromosome content underneath each individual in your pedigree. Now, if you're assuming X-linked recessive inheritance, where do you start? The easiest place is to start with affected males, because you know that the affected males must have one copy of the recessive allele. In other words, they're hemizygous for the recessive allele. Affected females must be homozygous for the recessive allele. In other words, if a female is affected for an X-linked recessive trait, both of her X's have to carry the recessive allele. Now, the next place would be unaffected males. If it's an X-linked recessive trait, the unaffected male must be hemizygous for the dominant allele, because that's the only way that he's unaffected. Where the dilemma comes in, where there's a question in figuring it out, is for unaffected females, because unaffected females could either be homozygous for the dominant allele, or they could be heterozygous. And again, the way you're going to have to figure that out is either by looking at the parents or by looking at the progeny they produce. Because if they produce one individual with the X recessive trait, then we know that that female has to be heterozygous. Now, for the second statement, if you assume X-linked dominant inheritance, where do you start on the analysis? First of all affected males would have to be hemizygous for the dominant allele. Again, they only have one copy of the X, and if they're affected for a dominant trait, they have to have the dominant allele. All unaffected males must be hemizygous for the recessive allele, and all unaffected females must be homozygous for the recessive allele. So again, the question here is going to come with affected females, because the affected female is either homozygous or heterozygous for the dominant allele. Again, to figure out, you want to look at her parents or look at her progeny, and depending on the evidence, you might be able to make a decision. So this is the second set of guidelines. Now, I don't have a different slide for where you start on Y-linked and mitochondrial, but let me just talk with you about that for a moment. A Y-linked trait will only be observed in males. So if you see a pedigree where a male is affected and he passes the trait on to all of his sons, and in turn they pass it on to all their sons, and it can never be passed on to a daughter, or a female could never pass it on to the sons, then you know it's a Y-linked trait. So Y-linked inheritance shows a very specific pattern of inheritance. Affected males produce all affected sons. Unaffected males produce no affected offspring. In mitochondrial inheritance, you'll remember that mitochondrial traits are inherited maternally, meaning from the mother. So a pattern for a mitochondrial trait would be a mother who's affected passes the trait on to all of her sons and daughters, but only her daughters can pass it on to their particular progeny. In other words, a male affected for a mitochondrial trait, if he has children with an unaffected female, then all of the progeny will be unaffected, because the unaffected female gives the mitochondrial DNA to the offspring. So guys, you may need to go back and listen to this one more time, and you may need to write it out on a piece of paper so, again, that it makes sense to you. Don't try to memorize these statements. Instead, what you want to do is actually understand them. And so you're going to have some problems that it will give you some additional practice and demonstrate that understanding.